So, we've all gotten pretty used to chatbots, right? They're amazing for answering questions, writing emails, that kind of thing. But what if I told you that's just the tip of the iceberg? Behind the scenes, a massive shift is happening, moving us from AI that just talks to AI that actually does things. We are officially entering the age of the AI agent.
Okay, let's break this down. On the one hand, you've got the familiar chatbot. It's totally reactive. You give it a prompt, it generates a response. It waits for you. But the AI agent? It's proactive. You don't just give it a prompt, you give it a goal. And then it goes to work, all on its own, to achieve it. This is the fundamental leap we're talking about, going from just conversation to real-world action.
So, what does that really mean in practice? Well, just think of an agent as the next evolution of a large language model. It's like we've given that brilliant text-generating brain a set of hands and a to-do list. It's not just a writer anymore. It's an autonomous project manager that can actually interact with the world.
This table really nails the key differences. An LLM is all about text. It has low autonomy, it's basically stuck waiting for your next prompt, and it can only remember what's in the current conversation. An AI agent, on the other hand, is a whole different ballgame. It's action-oriented, it's self-directed, it keeps track of its progress with a persistent memory, and, most importantly, it uses tools like APIs or code to actually get things done.
Okay, so how on earth does an agent actually achieve this autonomy? It all comes down to a continuous, four-step thinking loop. This is the secret sauce that allows it to perceive the world, make plans, and learn from its own actions.
This right here is the core agentic loop. First, it perceives, gathering data from its environment. Then, using its LLM brain, it reasons and plans. It takes a big, messy goal and breaks it down into small, manageable steps. Next, it acts, executing those steps using its tools. And finally, and this part is critical, it learns and reflects. It looks at the outcome, figures out what worked and what didn't, and gets smarter for the next task. It's a constant cycle of doing and improving.
The engine that makes this all possible is a really powerful concept called the REACT paradigm, which stands for reasoning and action. Basically, it's a technique where the agent thinks out loud before it acts. This process of creating an internal monologue allows it to figure out complex problems and even correct itself along the way.
And here's a perfect example of what that reasoning step looks like. Before it does anything, the agent formulates an internal thought, a plan of attack. It's strategizing. It's not just blindly executing commands, it's figuring out its next best move.
And then boom, right after that thought comes the action. You can see it right here calling a specific tool, one designed to read an Excel file to execute the plan it just came up with. This constant, tight cycle of thinking, acting, and then observing the result is what gives it the power to navigate complex tasks.
Now, it's really important to understand that the word agent isn't one size fits all. It's actually a whole spectrum of capabilities, from really simple rule followers all the way up to highly advanced self-improving systems. Let's take a look at the 5 main types.
We start at the most basic level, with the simple reflex agent. This thing operates purely on if-then logic. If it sees X, it does Y. It perceives and it reacts. That's it. Its biggest limitation? It has no memory of the past, so it can't learn from experience. A thermostat is the perfect example. It doesn't remember that it was cold 5 minutes ago. It only knows the current temperature and follows its one simple rule. It's effective for sure, but also very limited.
Taking a big step up, we have the model-based reflex agent. The key difference here is memory. It maintains an internal model of the world, which allows it to understand and remember things it can't directly perceive at that moment.
Think about a smart vacuum. It doesn't just react to the wall in front of it, it remembers the map of the room. It knows which areas are already clean, and it avoids obstacles it's seen before. It has a memory of its environment, which makes it a whole lot smarter.
Now we're getting to the goal-based agents. This is where that shift from reactive to proactive really kicks in. These agents don't just follow simple rules. They have a destination in mind, and they actively choose the actions that will get them closer to that goal.
A utility-based agent is even smarter. It doesn't just find a path to the goal, it finds the best path. It weighs different factors like speed, cost, or maybe safety to maximize its utility, which is just a fancy way of saying its level of success and efficiency.
And finally, at the very top of the spectrum, we have the learning agent. This is the most powerful type because it can actually improve itself. It has a feedback mechanism that lets it learn from experience and refine its strategies over time. AI chessbots that play millions of games to get better are a perfect example of this.
So, we understand the different types now, but how are they actually built? Well, it really comes down to 4 core components, all working together.
It all starts with the LLM, which acts as the agent's brain for all the reasoning. Second is memory, both short-term for the current task and long-term to learn from past experiences. Third, and this is absolutely key, are the tools. These are the agent's hands, allowing it to do things like search the web, access a database, or send an email. And finally, you need an orchestration framework. Think of this as the glue that connects everything and manages the entire workflow.
When you combine all these building blocks, you start to get a glimpse of a future that is fundamentally agentic, a future where autonomous systems are going to tackle incredibly complex problems. But the true frontier here isn't just a single all-powerful agent. It's multi-agent systems. Imagine a team of specialized AIs, a researcher, a coder, a project manager, all collaborating on a complex goal, just like a team of human experts would.
And this isn't science fiction. It's already happening. One financial services firm plans to have over 200 agents in production by 2026, automating mission-critical business processes. The adoption is happening right now, and it's happening fast.
Ultimately, this all points to a massive shift. We're moving past AI that simply understands what we're saying. We are now building systems that actively pursue the goals we give them. This transition from passive understanding to active pursuit is what defines this new agentic era. This leaves us with a fascinating and maybe a little daunting question to think about. As these autonomous agents and agent teams become more and more capable, what's our new role? How do we best apply human creativity, strategy, and oversight in a world where the doing is increasingly automated? That's the challenge and the opportunity that's right in front of us.